Okay, good morning everyone. My name is Dr. Angesh Anupam. I am Head of Department for Data Science at Cardiff School of Technologies, which is a School of Technologies within Cardiff Metropolitan University in the UK. And I'm joined by my colleague Dr. Joel Penne, and we are here as part of the Global Wealth Project. And in a moment, I'm going to talk a little bit more about what this project is all about and what are our intended activities for the entire 1 week. So before I start, warm welcome once again. Let me try out some Vietnamese pronunciation. Xin chào. So I'm not sure if I made it right or not, but again, the point is that I am thankful for such a warm hospitality you have shown this morning, and we are glad to be here on your campus. And I'm sure that this collaboration, the one we are going to start today, is just a starting point. There are a lot many more things yet to come, and we'll chart out our plan for the next set of activities in the coming days. So, talking a bit more about Cardiff Metropolitan University, so this is where we are. We are based in two campuses. One is Randolph campus and the other one is Keen Quad campus. It's hard for me to explain what these pictures signify, to be honest, because they're taken from, it's like a top view, which could give a glimpse of different buildings and the departments we have within the campuses. But the idea is to show you that how green we are and how we have developed our facilities in the past year. So School of Technologies in particular is something which started, I think, like 5-7 years ago. It's not a very old school, but the good news is that we have grown a lot in the past 7-8 years, despite the fact that there was a pandemic for 2.5 years. There were some activities which we couldn't do as we wanted, but considering all those disruptions, we still made good progress. We do have a good profile of undergraduate programs in computing, in data science, in engineering, and on top of that, we also have some good programs for the postgraduate at the postgraduate thought level, which we call as MSc. We also have a very good community of doctoral researcher, PGR students. At the moment, if I'm not incorrect, we have approximately got about 50 PhD students within School of Technologies, and it's just one school within university. So we have got more than one school. We have got School of Management, we have got School of Sports and Health. There are so many different schools, but I'm just talking about School of Technologies. And looking at the way we engage in teaching and research, I'm sure we are going to do a lot more impactful activities in the coming years. And this project, as I'll explain in a moment, is part of those activities. We have shown significant progress when it comes to the student recruitment and staff recruitment. We have got altogether, I think, more than 56 academic staff in 2023. We started with just 14 academic staff in 2018, and you can see that in 5 years of time we have grown to 56. Likewise, we had got about 5 undergraduate programs in 2018. Now we have got around 12. 4 PGT postgraduate thought programs in 2018, and now we have got about 6. And on top of that, we are also running some interesting micro-credential courses, which we are kind of designing for the people who work in industry and people who want to do some upskilling of what they're doing. They join these kind of micro-credential courses. People who want to do it in a more kind of formal setting, they can also join our degree apprenticeship course. We have some interesting degree apprenticeship courses, such as in data science, where people working in industry, they join our undergraduate program. They spend some good quality of years within university, and in the end they qualify with a degree. Now, as this project is more about research and innovation activities. I'm going to throw some more light on the different types of research activities we do within School of Technologies. So we have got a Center for Creative Computing and Research, which we also call as CCRC. We have got the Research Center for Industry 4.0 and Blockchain. We have got a dedicated Center for Cybersecurity Information Network. We have got Eureka Robotics Center, who do a lot of interesting work in social robotics, like how robots can be used in for social work, like educating children, supporting healthcare professionals in hospitals, and there's so many activities which we can do using those humanoid robots. So that's primarily the activity for the Eureka Robotics Center. We also have a newly established research center called Center for Research in Intelligent Sensor and System. And I'm sure that in the coming few years, this may again expand or may take a form of 2 or 3 different research centers on its own, because at the moment it's dedicated to most of the engineering activities that we do within School of Technologies. On top of these research centers, we also have got 2 research groups, which can become a research center in coming few years' time, depending on the volume of projects done by the research group. So one research group is Bioengineering Group, which is led by Dr. Barry Bentley. The last one is which I'm talking about is Net Zero and Sustainability, which is led by me. And this project, in a way, is very much aligned to the activities we do within net zero and sustainability. So not today, but I think there is going to be one dedicated session where I'm going to talk a bit more about the different activities we do within this net zero and sustainability, and particularly the research we do about sustainable agriculture, smart farming, and how those research contribute towards the UN Sustainable Development Goals. So that's coming up soon, but in this session, in this presentation, I'm going to again sort of elaborate on the broader aim of this project for which we are here in Vietnam. So the aim is to do some workforce training in data-driven computational modeling and simulation for sustainable agricultural scenarios in Vietnam. So as the name sounds very broad, and the reason it has been kept at such a broad level is because this project is more about scoping activities. It's more about understanding how colleagues in UTC work, what kind of collaborations they want with us when it comes to sustainable agriculture, when it comes to the uses of computing and data science in sustainable agriculture. So it's more about understanding each other, and therefore the broader theme has been kept a bit broad at this point. But by the end of this week, when we again sit down together on Friday, I'm sure that we'll have some more narrowed down set of activities which we would plan to perform in the coming years, and that's the plan. So let me set some more context about why this is important. So I'm sure there is no disagreement on this fact that by 2050 there will be more than 9 billion of people on the planet. And when I say 9 billion of people, I'm sure in the audience everyone would agree that there is a vast majority of population in this 9 billion who come from this part of the world. When I'm saying this part of the world, I'm referring to the Asian countries, including countries like China, India, and Southeast Asian countries. So the increase in population, of course, brings some more challenges and some more opportunities, like how we can cater the need of the society, how we can make sure that the living standard of the people are as it should be. So there is an expectation that with this kind of increase in population, there would be demand, 50% more demand for the need for the food, for water, for energy, and so many different essential things that we need. the complexity of the problem get even more severe with the advent of climate change. Now, I'm sure people would agree here that climate change is something which is which brings lots of challenges, and it's not confined to one country. I think every country on the globe are trying to find out sustainable ways how to deal with climate change, how to find solutions for mitigating the impact of climate change, how to adapt with the climate change. So there are so many things which come up with the climate change, and this problem of food security is, again, like many other things, this is also going to have be impacted by the impact of climate change. So what we can do, I mean, what role technology can play to tackle this sort of challenge, that's very interesting to understand. So that's a bit about context, the broader context, but how does it connect specifically to Vietnam? Of course, the things which I mentioned on the previous slide are relevant to Vietnam as well, because Vietnam is also a country in the world, and it shares, the contribution Vietnam is making in terms of population and the energy requirement, food requirement. So it's everything applies to Vietnam as well. But on top of that, Vietnam, as we know, is having a long coastline and is one of the most vulnerable countries as far as the impact of climate change is concerned. Because of this coastline, if there are global warming, if there are increase in the water level, then there are more risks compared to many other countries in the nearby geographic region. So the complex problem of meeting food security while minimizing the impact of climate change on soil and the environment requires a more holistic approach and the uses of technology. Now, when we talk about technology, it has got a very wider implication. Technology doesn't just mean enhancement in machines, enhancement in manufacturing unit. Technology is everything that we can think of computing, everything that we think of making impact on the quality of life, on society through innovation. So there can be so many different types of technology, but the important thing is that before we go and start implementing technology, we first need to understand what is the system of interest. So this scoping of the system is very much pertinent before we even think of applying relevant technologies. And when we think of a system, it has to be a holistic approach, because it's a very complex world. There are so many systems within a system which depend on each other, and the impact of one subsystem on the other subsystem can be very complex to model, and this is why it becomes very much important to understand what we mean by system, what are the external entities, what are the internal entities, and then depending on that, then we can plan the relevant types of technology and interventions that needs to be done to solve some of the problems. So computational modeling of complex agricultural system can enable us to simulate the scenarios of sustainable and climate smart farming in Vietnam. So the question is that why do we need computational modeling? Can't we just go and start implementing things as it should be? So for example, if we know that there are some ways to reduce the emission, to bring some modern technology in farming, can't we just go and start using that without modeling? Yes, we can, but the problem is that if we don't have an idea of the implication that technology would have, or the scenarios that we are trying to run, there could be a risk that we might end up compromising on some of the variables, and that some of those impacts could also be irreversible. So it has to be. So we have to bear in mind that whatever we are doing is sustainable, and at the same time, we are kind of making an informed decision, thinking of all the various scenarios. The slide on the screen is a collection of 17 sustainable development goals set up by the United Nations. So United Nations, which we call in short as the UN, has proposed these 17 key areas where we need to think of the sustainable ways of developing or working, because if we don't do that, we might end up being in a situation where our future generation will not have access to the resources which they need to survive and to have good quality of life. So the first one, as you can see, is no poverty, but this project is more about looking at the second UN SDG, which is about zero hunger. And I think to an extent it also connects with the SDG number 13, which is climate action. And in addition, it also connects to an extent to SDG number 15, which is life on the land. And if we consider these three UN SDG, which is zero hunger, climate action, and life on the land, we can imagine how significant these SDG are when it comes to food security, when it comes to the impact of climate on food security, when it comes to the quality of life on the earth. So we need to be very careful about any policy measures that we are going to implement. We need to be very careful about any technological intervention, and we need to have a holistic plan, as I mentioned. So in the coming few days, throughout the week, when we will be running some sessions, to an extent we'll be confined to these three SDG, and we'll talk about various ways how technology, how modeling, how data-driven models, how computing technologies, they can be used to address some of these UN Sustainable Development Goals. So again, going back to the basic, why we are here and what's the reason why we are in Vietnam. So this project is funded by the Welsh government, and to be more specific, there is an institution which we call as the Global Wales, which is a partnership between universities in Wales and the Welsh government. And its primary aim is to promote Welsh higher education internationally, fostering collaboration between Welsh universities and the institutions worldwide. It seeks to enhance Wales' global presence in education and contribute to its economic and social development. But it's also about internationalization, as you may have noticed in the point number 2. So there are some priority countries for Global Wales, and I'm glad to say that Vietnam is one of the priority countries where we are trying to start some new collaboration on top of some pre-existing collaboration, and see what else we can do together, and to come up with a plan so that in future then we can select the appropriate grants, appropriate project, which could be funded by Global Wales, which could be funded by British Council, which could be funded by Vietnamese government, which could be funded by other agencies, including such as UKRI and so on. So the aim for this week is to identify those areas where we can work together, and once we identify those areas, then it would be a lot more easier for us to look at the right pot of money and the project where we can work together. Now, before I go further, let me again take a step back and describe a bit more about what we mean by systems thinking, because if I remember, I used the term called a holistic approach, a system approach, but what it is actually, I mean, how we ensure that we are thinking a system as a system and not as an individual component within the system. So the holistic perspective is that the system is is an interconnected thing where there are so many parts within the systems called subsystems which are connected to each other, and there is an impact of one subsystem on the other. So to break it down further, let's consider for example, agricultural production system. So we have got soil system, we have got vegetation system, we have got irrigation system, we have got a system to use fertilizer and so on. Now, if we combine them together, then this becomes like an agricultural system. If someone says that I can only think of vegetation system without considering too much about soil system, then that's not the right way, because a soil system will have substantial impact on the vegetation system, and likewise. So for example, if we are producing the crops which are not having so good impact on soil system, then maybe not immediately, but in coming 5, 10, 20 years of time, you may start noticing the impact of that particular crop production on the soil, and that impact could also be irreversible. So in a way, what I'm trying to tell here is that for any complex process, such as including agricultural process, it's very much important to understand, to define the system. And how do we do that? There is a well-structured way to define the system. And once we have got an idea of what a system consists of, then we can start planning the activities which we want to implement on a given system. In this project, in this entire week, I'll talk a lot about computational modeling. So I'm taking this opportunity on day one to kind of give some heads up about what different types of computer models we have, generally speaking, and what you can expect from each type of computational model. Of course, every type of model has got its own advantage and disadvantage, and when it comes to making a decision which one to select and which one not to select, you need to know in advance all those pros and cons of choosing a particular model. So the one classic type of model is called process-driven model, sometimes also known as physics-driven model, where you know the fundamental laws of physics, physical system, the biological system, and you use those that information, the governing equation and the information about the system, to model the system using some established technique, such as, for example, finite element modeling method, where you consider the basics of a system and the governing equation and so on, and you use some of those equations to come up with the model. But the downside is that to come up with a good process-driven model, you need to have a very, I would say, an ideal knowledge about the system, the underlying system, which is not so easy. You also need to model the complexities, and it has been proven that although in theory this seems to be an ideal approach, where in a way you are modeling based on the knowledge about the domain, based on the knowledge about the system, but in reality the implementation has not been so easy. And there are some examples which we can explore further in the coming days of this week. But in short, I can say that yes, in theory it looks nice. This should be this seems like the most elegant way. But when it comes to the practicality, this is not so easy because of the complexity within the system. Because of that complexity, it's not easy to model that accurately. So the other approach is known as data-driven model, where instead of using the governing equations, the underlying knowledge about the system, we can think of the data which is generated by the system. So I can give a very simple example for the audience who perhaps have not worked with any of this kind of computer model. So we as a human, we are also a very complex system. So for example, if I am here in Hanoi this morning, I'm a system. I'm generating some data based on how I'm talking, my accent, the knowledge about my subject area. You can start judging me. You can start making some assumption about me. You can start making an informed decision that how I would be behaving in the coming few days, just because you have heard me for the past 25 minutes. And this is data, so you don't know me for a very long time. You have never seen me before today, but despite that, you can make some informed decision about me just based on the information I'm generating at the moment. So it's the same analogy. So the system can be complex, like the human system, as I said, but you don't necessarily need to know everything within the system. If you have got access to the data being generated by the system, you can still come up with a model for two purposes. One is, of course, the forecasting, the prediction purposes, to see how the system would behave in future, but that's not everything. And there is a big misconception that when we talk about data-driven model, empirical model, AI, people always think that it's about forecasting and prediction. That's one side of the coin. The other side is also to think of something differently, that even a data-driven model can give you a glimpse of what system consists of, and it may not be a very direct representation, but it can still give you an indication that how different parameters within the system are connected to each other. And more specifically, we class that kind of data-driven model as a gray box model. It's not a complete black box model. I mean, if you go and look around the various black box model, yes, you can use data to derive those black box model, which could be also very useful for the forecasting purposes. But the type of model which I'm describing here, or I'm trying to, I'll be talking in the coming days of this week, is more about data-driven approach, but it's more about the gray box modeling approach, where you use the data to generate the model, but at the same time you can also see what a system looks like from within. And I think that's going to be very interesting. And I'll show you some examples because this is day one, this is just the first session, and it's more kind of giving you a picture of what to expect in this week. But I'll give you some more examples. But before that, before we go to that stage, I think that will happen on Wednesday. Tomorrow I'm going to talk about one process-driven model, which is very popular, and I think I've shared some information before coming to Vietnam. But no worries if you haven't seen that before. I can again share. I'll do a proper briefing session to explain how to work with that model, and the second part of the session would be a hands-on exercise where you can actually work along with me and see and do some interesting scenario evaluation. Essentially, you can for example, you can simulate condition, the Vietnamese condition. You can simulate what will happen to a particular type of crop in the climatic condition of Vietnam. What will happen if there are some climate change in the coming 20-25 years? You can use the same model with the different parameters, obviously, to simulate what will happen if we look at the UK condition, Wales condition, and so on. So it will give you a very interesting comparative idea about how different climate how different climate have impact the vegetation system, soil system, and so on. So probably we are going to do this activity tomorrow, and day after tomorrow I will be talking more about the data-driven model. So before I go any further, let me see if I can show you this moment. This could be tricky with the system we are using, but let me see if I can access that Word document. So the idea is that today we are doing this session. The first part is already done, meeting with colleagues at UTC Hanoi, and this presentation was the intended activity as the second session. On June 4th, the first thing we are going to do is to talk about a process-driven model, and in the second part of the session, I would appreciate if you could join me and do some hands-on exercise on that model. On Wednesday, I'm going to talk a bit more about data-driven grey box modeling approach, which would be interesting in the context of agricultural production. In the second half, my colleague Dr. Joel Penny, he will come up with some interesting hands-on session, which I'm not quite aware at the moment, but I'm sure he has prepared something very exciting. And before I end the session, I'll hand over to my colleague Joel to talk a bit more about his background and what has he planned for this week. So before we conclude our session on 7th of June, the 6th of June is when we'll be talking more about our research, because the Tuesday and Wednesday, these 2 days will be devoted for, as we said, the capacity building kind of thing. We'll be doing the workshop to inform some of the techniques, inform about some of the techniques and the methods of in the modeling. But on Thursday, we'll talk more about our research, the research center we belong to, the research group I'm heading. So we'll talk more about those things on Thursday. And likewise, my colleague Dr. Joel Penny, he's also going to talk about his research. And on June 7th, we will do a final kind of conclusion where we'll sit together, we'll plan out the activities for the, not just for this year, but 3 years planning, 5 year planning, 10 years planning, and like that. So as this project is more about knowing each other to to start a collaboration. But before we end this week, we would like to have some plans about how we intend to build on this collaboration, what different things we can do as part of this collaboration. So before I wrap up my presentation, may I request Joel to give you a very kind of a quick introduction about yourself and what have you planned. You don't have to be very specific at this moment, because this is more about telling the people what we are intending to do. So over to you, Joel.
No problem. Yeah, good morning, everybody. So thank you, Dr. Angesh. So I'm Dr. Joel Penny. I'm the Program Director for Computing with Creative Design and Business Information Systems in the School of Technologies. So of course I work very closely with Dr. Angesh. Now, a lot of the work that I do at Cardiff Metropolitan University in the School of Technologies revolves around computing with creative design, so exploring areas of user research and usability studies. But my other area of interest is in robotics, which is mainly where my interest for this trip to Vietnam originated from, and my work with a group that we call SGF, which is the Sustainable Growing Futures, as part of Cardiff Met. Now, as part of the interactive session that I've got planned is more surrounding the robotics aspect, so exploring how we can use robotics in agriculture, and I'll be giving you many examples of how we use technology and robotics as part of Cardiff Met and as part of SGF fields, which will be mainly around the hands-on activity. The research seminar then is where I'll come back into my more PhD research and my other area of interest, which is usability. But once again, it'll be tied back to exploring usability aspects of the agricultural robotics and what we need to explore, but also giving you insight into some of the work that we do at Cardiff Met in robotics, as we are one of the 16 centres in the UK for robotics. So we're very well established, and hopefully it'll give you a really good overview of the type of work that we do, not only in the agricultural sector, but the other sectors in which we use robotics, such as healthcare, and many other sectors which I'll touch upon in the research talk. So that's a very brief overview of what's to come. So thank you very much, Dr. Angesh.
Thanks, Joel, for your introduction. And this was all about from us this morning. I hope this session is going to be useful in understanding the context of this project. It was more about setting up the scene, talking about the various things we can do together, but more, I would say, the interactive exercises would begin from tomorrow. But before that, before we wrap up the session, if you have got any question, feel free to ask us. Or any comments or any suggestion.
Thank you very much for the presentation. So I have questions from the audience. So the question is, do you have any something like sabbatical programs or exchange programs between the professor of University Cardiff, the university, especially in Vietnam?
Okay, thank you. Thanks for asking that question. So it's not on top of my head at the moment, but I was talking to your colleagues in the morning, at the moment when we arrived here. There are some exchange programs, not just with Vietnam, but with many other countries. What I'll do, I've already shared my contact details, and I'm going to stay here for the entire week. Whosoever is interested to know more about this kind of program, they can reach out to me, and I'll signpost them to the right point of contact within Cardiff Metropolitan University, who can advise more about what exactly that program is and how they can engage with us. But since I don't have the details, so the only thing I can do is to signpost. But I'm sure there are something like that.
Thank you.
Is there any other question or comment from the audience?
Check. Yeah, someone's raising his hand. Mr. Phạm Huy Hoàng. Sorry, we cannot hear the mic from. We cannot hear the voice from the audience. Mr. Phạm Huy Hoàng, maybe can you check your microphone, or you can type your questions here? Maybe you can type your questions at the moment, because your microphone, you cannot hear it. Here's the questions, but I think his microphone is not working.
No problem. If they can type the question, you can read out the question, and I'm happy to answer.
Maybe I have another questions regarding these projects for the AI models for agriculture sustainability. Is Vietnam your only countries in Asia that you have spent your focus on for these projects, or are there any other countries in Asia? Southeast Asia?
Okay, that's a very good question. So at the moment, the answer is that it's hard to answer if it's Vietnam is the only country, but I can certainly say that this project for which we are here is focused on sustainable agriculture, and it's just Vietnam with which we are engaging. But as my colleague Joel said, that we also have partnership with some other institutions in Asia, like Malaysia, Indonesia, those kind of countries. It may not be directly about sustainable agriculture, but even if it's about some robotic application in farming or in smart agriculture, then yes, technically that counts as a smart agriculture, right? So this is why I said it's not easy for me to answer. But this project, as you can see, the theme of this project is all about smart farming, smart agriculture, and within Vietnam, UTC is the institution with which we are collaborating. So that's the answer I think I can give.
Okay, thank you.
But yeah, just to add on that, certainly Vietnam is one of the key priority area for the government of Wells. So I talked about Global Wells and how this project has been funded with the help of Global Wells. And in Asia, Vietnam is one of the top priority country. For I think there is another country in Asia called India, and then we have got 2 or 3 other different countries, but not in Asia. So certainly Vietnam is one of the key priority country for us.
So now I've received the questions from Mr. Park Bi-Hwan. And the question is that he wants to ask what kind of robotics was used in your research and what topic was it about, like rice or soil quality or something?
Joel, would you like to answer
Yeah.
this?
So there's our research projects range in terms of robotics. So like I said, we use a lot of robotics in the healthcare sector, which are mainly humanoid robotics. So they come from a company called Sandbank. So we use robotics such as the Now robot, Pepper, JD. There's a wide range of robots. We have smaller ones called Cambot, and mainly they're used for sort of rehabilitation, but they're also used to transport materials in hospitals. Now, from a agricultural perspective, we have different robots which we're using. We've engaged with a company in California who've developed a robot or a farming system called the FarmBot. Now, essentially, the FarmBot, which I'll talk a little bit more about in the research presentation, the FarmBot is almost like an all-in-one package. Now, essentially, what this robot does is that it will plant seeds, it will water seeds, it has soil sensors. So there's many different attachments that the robot can go and connect to, and I'll show you video demonstrations in the research talk. But essentially, we program the robot to do different tasks. So one of the tasks might be to check the soil 3 times a day at specific intervals, and then if it detects that maybe the soil's too dry or that it's too wet, then it can act accordingly to pick up another sensor or another tool which could then water the plants or to monitor them. Now, there's lots of other sensors on this robot and things such as cameras as well, so we can monitor the robots when we're, for instance, in Vietnam. We can see the output, which hopefully I'll demonstrate some of that for you in the research talk. Now, other robots that we use as well, mainly sort of non-humanoid robots. So for instance, they're just the arms, so we can program arms to do different tasks such as, again, water or to pick plants. One project that we're hoping to develop over the next year is to do a comparison between humans taking care of a simple plant and then a robot taking care of a simple plant. So we'll set up this controlled experiment to see, how often a plant needs watering compared to how often the robot thinks it needs watering, just to have sort of a comparison to see whether or not robotics could be used on a larger scale. Now, as we develop our project using the FarmBot, we're hoping to take it to the next stage. So currently the FarmBot is only a small patch, so it's around 2 meters by 2 meters, so it's around a square, small patch on our campus which we're currently using. But as we develop it further, we'll start exploring things such as drones and other mechanisms which we can use for much larger scale projects. Thank you.
Thank you very much for your answer. Is there any other questions from the audience? Maybe I have another questions regarding, because in agriculture, I think there are a lot of environmental factors that can affect the data that you collected. So, what are the measures you take to ensure that the data you collect are usable, are smooth, and there are not a lot of noise that can contaminate the data?
So there are some well-established techniques and algorithms within data science which can identify if the data is consistent or not. So consistency is the key. So let's say if we have got a sensor system which is not working correctly, and that's the only system we have got, then it's hard to detect if the data is noisy or if the data is clean. But if we have got a set of sensor system, and if we are not just depending on one of those sensors, then we can make a comparative analysis to see if the data we are receiving from those systems are in that range or not. If we find any severe mismatch, then that is an indicator of data being corrupted by noise. Noise removal, detection, this is not just confined to the agricultural system. This is a wider issue for any data-driven algorithm and application. And this is a work in progress, I would say. People have been researching for many decades, I can say, but still there are some scope where we need to improve. So the short answer is that as we sometimes call about our investment plan, that don't invest in one share or in one fund, try to diversify the portfolio of investment. Likewise, when you are deploying the sensor system for the measurement, don't just bank on one type of sensor or one type of system. Diversify, so that then it would be easier for us to detect any such measurement noise. But I can talk a bit more about that, because this is very much connected to my fundamental research interest. So I can talk a bit more about on that. There are some established statistical algorithms which make sure that even if data is corrupt is not the right word, even if the data is somewhat noisy, can we work through that data or not? So there are approaches. In simple terms, if you follow the statistical approaches, statistical signal processing technique, you can work with some kind of noisy data. But if the signal to noise ratio is something where it's just noise and not so much of signal, then it becomes very difficult. So this is what I can answer, that it's a complicated problem, but yes, there are ways to work around that.
Thank you, sir. And I also hope to see it more on your presentation about your research.
Yeah.
We can understand you.
Thank you. So the research presentation will take place on, I think, Thursday, not tomorrow. Tomorrow is more about training on a given model. So there is a process-driven model, which people have been using for the past 8-10 years. And in tomorrow's presentation, I'll talk a bit more about how you can use that model, how you can make sense of the result generated from the model, how you can parameterize the model. So the first part of the presentation would be training the audience how to use the model, and in the second part, I'll come up with some hands-on exercise where you can start working on that model. So that's so what it means is that tomorrow I may not be talking more about these things which I mentioned, the data-driven approach. But one request is that so the model which I'm going to talk tomorrow is a Windows-based model. So if you could request audience to join the tomorrow's session with a Windows PC or a laptop, that would be great, because they need to download a zip file, extract the file associated of that model together, and then run that on a Windows machine. Okay, so that's just one requirement before tomorrow's session.
Thank you very much. I will make sure to pass the information
sure.
out to the audience.
Thank you.
Mostly in Vietnam, we use Windows PC.
Okay, good. Yeah, the reason I said, because we both are Mac users, you can see. So I said I should give this as a kind of a heads up before we start tomorrow.
Okay, thank you.
So if it's all, then shall we wrap up the session, or is there any other question?
Yeah, I think there is no other questions from the audience. Maybe they will have more this afternoon. So thank you very much for your brief introductions this morning. So we hope to continue with you in this afternoon.
Yeah, thank you.
Audience as well. So if anyone has any questions, maybe you can just send us. We can send back to the two professors. Okay. Oh, sorry. There is one last question for this morning.
Mm-hmm.
He just said to me, where can we find your? Where can I research your group's topic online?
Sorry, say again.
Where can I research your group's topic online? Maybe you have a website.
If you're looking for specific research from us, you can of course go and find on internet with our name. You'll find that. But if you are looking trying to find more about the work we do in different research center, then the best way is to go to Cardiff Metropolitan University's website. Within that, you can dig further into School of Technology's website, and you'll find information about the research center. But unfortunately, the page is not very well updated at the moment for various administrative reasons. So you may not be able to find every single detail of what I've covered today and what I'll be doing. So, but still you can get an idea of what different things we do.
Okay. Thank you.
Okay.